I am Sunil Rathod, HOD and Department of Physics, Bangur Nagar Degree College. Today I am going to explain regarding GM tube and the dead time. We are going to find out the dead time of GM tube by double source method. Before going for the experiment, we will know what is a GM tube. This is an instrument which is used to detect the beta rays and gamma rays. Here, this instrument, Geiger counting system, this comes from the scientist name called Geiger-Müller. So this instrument has many, it has a dial set and start, stop, reset and the manual button, and also this is a main switch. Okay, so first I am going to explain how this works, what is the working of a GM counter. This is a dial set machine, so such that if I change anything by a certain voltage, imagine now it is at the 4 multiplied by 150, that indicates the voltage which is forming here at the GM tube, that is 4 into 150 is 600. Okay, and also if I change it to if I reduce it to the 3, then this indicates that now we have set an voltage 3 into 150, which is 450 voltage, which is built here in the GM tube cathode and anode. So this is an dial set which works like this. And also what we have to do for this experiment, we have to set it for an operating voltage. Operating voltage is nothing but it is an voltage where the instrument has minimum statistical errors, which at start indicates that the instrument we are going to run, and this is the stop to stop the count rate, and this is to reset the values and again to run the experiment. Again, this button indicates the time setting. It is time setting. The manual indicates that we can take it for an manually or for days together for a longer to run the longer experiment. Okay, and this 30 second, if I click on the 30, if I put this button on the 30, that means the counts are done only for the 30 seconds, and if it is done, click on the 60, then the count rate is counted till 60 seconds. So similarly for the 120 seconds. Now we explain regarding the GM tube. This is also a part of an GM counter. This GM tube indicates it has a GM tube consists of inert gases. It consists of inert gases such that the moment this is the place where we have to keep the sources. This is the place where we have to keep the sources, and the moment the radiation enters into the GM tube, which consists of an inert gas, has an anode at the center and the cathode at the surrounding. Radiation enters into a GM tube, it hits to the inert gases, and those hits release the anode. Those are converted into electrical pulses, and the electrical pulses later treated as the counts. If the electrical pulse width is very lesser, then in a window it is treated as a radiation of lower energy. And if the pulse has a maximum width, then it is treated to be the higher energy radiation. And in the window, that is treated as a count rate 1, 2, 3 that have converted into the electrical pulses. Now we have different beta ray sources in our lab. We are using cobalt, strontium, thallium, 204, and also there are some different sources called as cobalt, which has 2 peaks. So the cobalt of 5.27 years, and then the thallium has a 3.9 year, and the strontium has a 28.5 year half-life time. Dead time is nothing but it is the time during which the counter is incapable of representing to second ionizing event. This is our aim of the experiment. For that we are using the double source method and we are using the holder. So it to be used for the to find the dead time of GM tube by double source method, that the T equal to T, this is nothing but tau, it is a tau equal to I1 plus I2 plus I12 divided by 2I1 I2, where I1 is the count rate of the first source and the I2 is the count rate of second source, and I12 is nothing but the count rate taken when both kept at one time. For the procedure, as it is finding the dead time, we are using the double source method. The double source, in our studies, we are using strontium 90 as one source and the thallium 204 as the another source. And this is an holder which has to be taken for our study. Now fixed, that is, for this instrument, the operating voltage of this instrument is 540 voltage. Therefore I have set it for the 3.6, which is again multiplied by 150, which gives the 540 voltage. This we have set it. Now what I do, I take an holder and I put it in an here. Now if I keep only one source, then if I take it this and kept it, then it is indicating that now for the tabular column we started taking the reading for the I1. Okay, I repeat it. If when I keep only one source and if I start taking the reading, then it is for the only I1 source. Again after that we have to repeat it for the 3 times. Then we have to keep another source, which is second source. In our study we are taken as the cobalt. So this system for both the sources, it is treated as a I12. So the same experiment has to be repeated 3 times for both the sources. After the completion of the 3 readings of both the sources, now what I do, I remove the I1, and I only take the 3 readings for the I2. That I will write in the tabular column, that here so I repeat it for the here, and then mean of that has to be written. This is the. Now we start the experiment. I have kept as source I1, which is strontium, and now I take it for a start, and we have set the dial set for our operating voltage, and now we have set a time for the 30 seconds. What I do now, I will start an experiment. By clicking on the start buttons, and these are all the count rate for the I1 sources, which is we are going to calculate it for the 30 seconds. And also, so 502, we have got the count rate. Again I reset the button, I repeat the experiment for the same I1. So here the count rate is we get around the 502 for the first reading, and the 536 which we got for the second time. The same is performed third time and fourth time. We got 535 as a counts and the 526 as the counts for the 30 seconds. Now we are going to go for the I12. For that I keep another source here, such that we'll start an experiment now. Again we have to follow the same procedure, such that now I reset everything and I start the experiment for both the sources, which now we are going to treat it as a I12, and we have to count the for the 30 seconds. Now we got the 1013. 1013 is a counts of not only the strontium, it is inclusive of the thallium. Therefore we call it as a I12. And now the second time we got 1056, and the third time when we perform we get an for both the I12 sources as 1081. So we have to write down here 1081, and again I take it and a reset button, stop it, and I click on the start for the fourth reading of I12 sources. I take the I1 source out, and now we have to do for the count rate for the only I2. So for this, now I start it for the I2 source, such that only for the thallium sources we are going to find out, which we treated it as a I2. And the 30 second we got 583. Again I reset it and I start the experiment. Now we have to take it an I1 source as a out from the holder, and now we have to start it for the I2 experiment. Now for the I2 sources, what I do, I again reset the button and I start it. That is, the whatever I2 we have taken is as a thallium source. So these all counts is representing only for the thallium sources. For the 30 second, we got 621, and I repeat it for the same experiment 3 times. Again I have reset and I have started the experiment for the 30 second, which is a second time counting for the 30 second of thallium source. Again we got 621 only, and this is the repetition of the I2 for the third time and for 30 seconds. Here we get 591, and finally I start the experiment of the I2. And we obtained 594 for our I2 study. Now, after mentioning all the data counts, now I go for the initially, which is a background counts. That is nothing but without the source. That is the counts which we get from the environment or cosmic rays or ionized rays. Those all rays without the sources are known to be the background counts. To find the background counts, we should not have any sources in an GM counter. So I have taken out both the sources, and now what I do, I reset and I take the counts without the sources. As I have explained, the background counts are nothing but the counts without the sources. And for the background counts, we got for first time 0, and now it is 3. Again I repeat the experiment for the 30 seconds without the source. Okay, this time also we got the 2. Therefore, average of the background count, I take it as a 2. So this has to be subtracted from these datas, and mean of the I1 has to be get, and once we get the mean of these 4 datas, whatever values, that has to be subtracted with the background counts, and that has to be again written for the per second. The experiment which we have taken is all for the 30 seconds, and the count rate means we have to divide it by the 30 mean value or the corrected value. We have to divide it by the corrected value. Then whatever value we get, we have to mention it here. Okay. Now we go for the calculation part. For the I1, mean of I1 we got as a 525, and the mean of the I12 as a 1044, and the mean of the I2 as a 606. Again, this value has to be subtracted with the background count, such that we got the 523, and for the count rate which we have taken for the 30 second, that has to be divided, and we got it as a 18. Again for the 1044, that has to be subtracted with the background counts, and whatever value we get has to be divided by the 30 seconds, such that these are the 35 and 18 are count rates per second. Similarly, we get for the I2 20 counts per second, which we call it as a count rate. And after completion of this procedure, we go for the calculation. We know that the formula is I1 plus I2 minus I12 divided by 2 I1 I2. These values has to be these 20 and the 35 and 18 has to be substituted in these values, and we got this 400 microsecond. What it indicates is that the counter is capable of representing to a second ionizing event only if it has a gap of 400 microsecond. Hence, we found the deadtime of the GMQ of using double source experiment. Thank you.